Heathrow's Terminal 5. By March 2008, over £4 billion will have been spent and 20,000 people will have worked on the project.
Terminal 5 is needed because Heathrow Airport is full, basically. So Heathrow Airport caters for about 65 million passengers per year currently, and it's full, and it was actually designed to cater for about 45 million passengers. So it's bursting at the seams, and Terminal 5 will actually allow us to increase the capacity of Heathrow to about 90 million passengers a year.
Heathrow Terminal 5's main terminal building has been constructed on the site of an old sewage treatment works to the west of the airport. In just 7 years, an iconic building designed to handle 30 million passengers per annum with a dramatic free-spanning roof structure has been constructed. This programme looks at the engineering issues behind the construction of the building envelope, and in particular the innovative approach to the construction of the roof structure.
How do you build a 17,000-ton structure on the world's busiest airport, surrounded by one of Europe's busiest roads, in an area where there is no space to swing a cat?
On a project of this scale, you have to think about the way it's built when you're designing it, because otherwise it's impossible or uneconomic to build it. Just getting that amount of steel into the air is a piece of engineering in itself.
T5A's roof structure encloses a vast footprint of 396 by 176 metres. It's supported by 22 pairs of 914mm diameter steel legs that reach down to ground level in full height spaces just inside the facade of the terminal.
The structure of the T5A roof is essentially a great big portal frame, or an arch, if you like. The abutment, the circular hollow sections of the abutment structure carry compression, and they support the curved arch section of the rafter. That rafter carries predominantly compression, but it also gets bending moment in it from the action of wind load on the building.
At the outset of the design of T5, we looked at many different alternatives for the T5A roof, whether it be a long span roof or supported on a number of supports internally. And through discussion with the architects, the client, and other suppliers involved in the project, we chose together the long span roof.
The plan was to construct the roof in 6 phases. First, the central arch section of the roof was to be assembled, clad and pre-stressed at ground level. Then temporary works frames were to be used to position the abutment steel for each phase. Then the plan was to jack the centre section 30 metres vertically into position and bolt to the abutment steel.
The roof was actually built in several key stages. The first stage of which was constructing all the rafters. This is the main arch rafters at ground level on what we call the apron slab. That was at ground floor level. Each individual component was brought in really as a series of Lego parts, cleverly joined together with a key and internal bolting through a diaphragm.
At the same time as the rafters were being constructed on the ground, the end abutment structures were built on a temporary works frame. The whole assembly was then ready to be lifted. The operation was undertaken by 8 pairs of 180-ton strand jacks, coordinated by a sophisticated computer-controlled system.
The next part was then to join the roof module to the abutments by aligning the abutments to the roof module and connecting it through a series of bolts. The accuracy of this was absolutely fantastic, and it's a major achievement in terms of accuracy of mating.
With the connection made between the roof module and the abutments, the full 2,000-ton load of the roof module could then be progressively transferred to the roof. With this part of the operation complete, the temporary work could be disassembled and the framework for the abutments moved along the apron slab to a new position with a new lift created.
The critical parts of the operation was undoubtedly the mating between the roof module and the abutments. You had to make a connection between 24 points in Cartesian space, which was a fantastic achievement.
Erecting 17,000 tons of complex steelwork in just over 12 months stands as testimony to the dedication of the construction team. Key to the success of the whole project was the integration of design and construction teams.
We had a team that worked well together. They wanted to do this job like nothing else. And what we did, perhaps more than others, was talk. And we talked about it as a team, and we made certain that every little aspect had been catered for.
We have delivered here a building with huge spaces which we've never seen before in terminal buildings, with very high quality finishes which have been sourced from all over the world, and I think passengers will really feel that they're moving into a new age when they come into Terminal 5.